Dear students, today we will discuss about the calculation of metal-metal bond in the organometallic compound. So there are three different steps which are used to calculate the metal-metal bond. In the first step, we have to calculate or we have to determine the total valence electron in the entire molecule. It means that the number of electrons or the valence electron of the metal atom and the number of electrons which are contributed by each ligand and any charge which is involved in the molecule, and this whole term is denoted by A. In the second step, this A means the value of total valence electron is subtracted from n into 18, where n is the number of metals in the complex, and the term n into 18 minus A means the total valence electron, which is equal to B. In the third step, the first part, this term B is divided by 2 gives the total number of metal-metal bond in the complex. Whereas when we divide the A means total valence electron by the number of metal atoms, then it will give the number of electron per metal. So these are the three different steps which are used to calculate the metal-metal bond in the complexes. For example, Fe3CO12. So first step is we have to find out the total valence electron. If we talk about this complex, in case of iron, there are 8 electrons in their valence shell. The total number of iron are 3, then 8 into 3, and each carbonyl ligand will contribute 2 electrons. So there are total 12 carbonyl molecule, then 2 into 12, and in this way we will get 48 valence electron, and these are the total valence electron in case of Fe3CO12. So this is the first step, means A. In the second step, we have to subtract this A from n into 18 minus A, and n is the number of metal atom in the molecule. So there are 3 metal atoms. So 3 into 18, 54, minus total valence electron 48 will give you 6 electron. Then in the third step, this whole term is denoted by or represented by B. Then this B is divided by 2 will give you the number of metal-metal bond in the complex, and in the last step 48 divided by 3 means total valence electron divided by number of metal atom, these are 3, and you will get 16. It means each metal will have 2 electron, will give you 16. It means there are 2 metal-metal bond in the particular complex. So this is the basic geometry of this Fe3CO12. So there are 3 metal-metal bond. First one is these 2 iron atoms, second one, and this is third one. And the last, that is, you have calculated 48 divided by 3 is equal to 16. It means it indicates there are two metal-metal bond. Means each metal atom will have two metal-metal bond. Similarly, in case of CO4, CO12, there are total 16. There are total 60 valence electron. So in the case of cobalt, there are 9 electrons in their valence shell, and 9 into 4, 4 is the number of metal atoms, plus 12 into 2, then you will get 60. In the second step, n into 18 minus total valence electron. So n into 18 means n is number of metal atom, these are 4, and 4 into 18 means 72 minus 60 is equal to 12. And in the third step, this B term is divided by 2 will give you 6 metal-metal bond. So when we check the geometry of this CO4, CO12, there are total 6 metal-metal bond. 1, 2, 3, 4, 5, and this one 6 one. So in this way, we can calculate the number of metal-metal bond in the molecule. And this last one, Fe2CO9, there are total 34 valence electron. In case of iron, there are 8 electrons there in their valence shell. Then 8 into 2 plus 9 into 2, 18, 8 into 2, 16, plus 9 into 2, then you will get 16 plus 18, 34 total valence electron. In the second step, n into 18, n is the number of metal atom, and there are 2 metal atom, and 2 into 18, 36, minus total valence electron 34 will, and we will get 2. Then this whole term is represented by B, and B is divided by 2 will give you 1 metal-metal bond in the molecule. So there is only 1 metal-metal bond in the 2 iron. And when we divide the total valence electron, means A, by 2, then you will get 17, means there is only 1 metal-metal bond. So in this way, we can calculate the total valence electron as well as the metal-metal bond in the complex, and the number of electron with each metal.